Hi there, welcome to edupediaworld.com. You're watching the videos on circles. Now in this video we'll discuss how the angle subtended by an arc of a circle, how we can use this concept to solve the various questions related to the circles. Let's say if we have a circle like this, and let's say this is an arc and this is an arc, and suppose let's say this is a center, then how we can relate this angle, this is an angle subtended by an arc, this arc, how we can use this angle to solve various problems related to circles. Then we'll discuss some of the theorems related to this angle subtended by an arc of a circle. So let's get started. First we'll cover some introduction to this topic. Now, angle subtended by an arc. If two chords of a circle are equal, let's say if we have a circle like this, let's say this is an chord A, B, and let's say this is an chord P, Q, then their corresponding arcs are congruent. Means let's say if the chord AB and PQ are equal, that means this arc should also be equal, or they should be congruent, right? They should be of a same size and same length, we can say. And conversely means if the two arcs are equal, let's say the arc, this arc is equals to this arc, then the chord should be equal, vice versa, whatever we can say. Now if two arcs are congruent, then their corresponding chords are equal, right? So this is how we can use, like say, arc or chords to solve the angle subtended by an arc. Okay, now congruent arcs of a circle subtend equal angles at the center. Let's say if we have a circle like this, and let's say this is an chord and this is an chord. Let's say this is a chord AB again, and this is a chord PQ. Now let's say if chord AB and PQ are equal, that means what? This arc and this arc are congruent, right? Now let's say this is a center O. Now if this arc subtend an angle like this and this arc subtend an angle like this, then according to this concept we can say that this angle and this angle are equal, right? So this is how we can say that if the two arcs are congruent, then they subtend equal angles at the center. Now let's discuss the theorems related to this concept. Now let's discuss the theorem number 1. The theorem says that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of a circle. Means let's say if this is an angle subtended by an arc at the center, should be twice this angle. So let's say how we can solve this theorem. First of all, we need to write given. It's given that this is an arc. Let's say O is a center, we can say, right? Now what we need to prove? We need to prove that angle POQ is 2 times angle APQ, right? Means this angle POQ is 2 times angle PAQ, right? So let's say how we can prove this. So let's discuss the proof now. Now if you consider, say, triangle AOQ, right? So we can say that angle BOQ equals to angle OAQ plus angle AQO, or we can say that OQA. Why? Because if you can see properly, if this is a triangle AOQ, this is an exterior angle, BOQ is an exterior angle. So we know that exterior angle is sum of interior opposite angles. So this angle plus this angle, right? So we can say that, but can say that exterior angle is sum of interior opposite angles, interior opposite angles, right? We can say that. Now so if you see properly, AO is also a radius. If you see properly, AO is radius and OQ is also a radius, right? So we can say that AO equals to OQ, means this side equals to this side. Now, if in a triangle, if the two sides are equal, then the opposite angles are also equal. So we can say that angle OAQ will be equals to angle OQA. Why? Because AO equals to OQ. You can see properly. If these sides are equal, then angle opposite to them are also equal, right? So we can say that, or we can write angle BOQ as 2 times angle OAQ, right? This means this angle is 2 times this angle. Similarly, we can prove for BOP. Let's say we can write angle BOP will also be 2 times angle, let's say PAO, means this angle will be 2 times this angle. Similarly, by this way only we can prove. So let's say this is first and this is second. Now can say that adding 1 and 2, what we get? Angle BOQ plus angle BOP is 2 times angle OAQ plus 2 times angle PAO, right? Means BOQ, this angle, plus this angle equals to 2 times angle OAQ, this angle, plus this angle, right? Now we can say that angle BOQ plus angle BOP will be angle POQ. We can see properly. So we can say that angle POQ is 2 times, 2 we can take common, angle OAQ plus angle PAO, right? So we can say that angle POQ equals to 2 times. Now angle OAQ and plus angle PAO. So let me use another pen now. Let's say angle OAQ. So this is angle OAQ plus angle PAO. So this is angle PAO. So it will become angle what? PAQ, right? So we can say that 2 times angle PAQ. So this is how we can prove this kind of theorem, that angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of a circle. So let's move on to the next theorem now. Theorem number 2. Now, theorem number 2 says that angles in the same segment of a circle are equal. So we need to prove that. Let's say if this is a line PQ and they subtend equal angle in the same segment, like let's say if this is a line PQ or chord PQ and this is an arc. Now if this is an angle in the same segment, so this is a segment, so this is a segment. So let's say it line PQ subtend an angle PCQ in this segment, then this angle should be equals to angle PAQ in the same segment. So let's see how we can prove this now. So let's discuss. First of all, we need to write what we need to prove. We need to prove that angle PCQ equals to angle PAQ, right? So let's discuss the proof now. Now we can say that angle POQ is 2 times angle PCQ. Why? According to the theorem, angle subtended by an arc at center is double the angle subtended by it on any point on the circle, right? So this was a theorem. Now, so let it be first. Similarly, we can say that angle POQ is also 2 times angle PAQ, right? same theorem applies. So if you can see it now from equation, or we can say that from 1 and 2, if you compare 1 and 2, 2 times angle PCQ will be equals to 2 times angle PAQ. So this and this get cancelled. So we can say that angle PCQ equals to angle PAQ. So this is how we can prove these kind of theorems, that angles in the same segment are equal, right? So this angle PCQ is equals to angle PAQ. Now let's discuss the next theorem, theorem number 3. Now, so its theorem is very easy. Let's say if a line segment joining the 2 points subtend equal angles at other points lying on the same side of a line containing the line segment, the 4 points lie on a circle, means they are coencyclic. So let's say how we can prove this type of theorem. So let's say if we have a line, let's say AB, right, and let's say we have another point over here C. Now if we draw a circle around this point, let's say we draw a circle like this around this point. Now if this point, let's say if D point is over here, right, and now the circle doesn't pass through point D, right, rather it intersects line AD, let's say this point E, right. So we can say that then A, C, E and B lie on circle. We can clearly say that, or then we can say that, let's say if we draw like this, right, and like this, line like this, then we can clearly say that angle ACB will be equals to angle AEB, right. Now let's say if we draw another circle, and now let's consider this figure. Now this circle passes through point D, then we can again say that angle ACB is equals to angle ADB, right. Now what this theorem, what this concept trying to say is that if any point passes through the circle, then, or we can say that if any point lie on the circle, let's say we have 4 points over here, 1, 2, 3 and 4, then these 4 points are coencyclic, means they will form a cyclic quadrilateral, which we'll discuss in the next part of the videos. So how we can use the concept of cyclic quadrilateral. So this is all about the theorem. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.